Mr. P, I need help with this proportion problem.
Alright, call it in the air.
Tails?
Got lucky. Let's see what I can do.
You have a twin?
Oh yes, I'm Larry.
And I'm Gary.
Statistics.
Alright, let's go work on this problem.
Alright.
Statistics. Okay, this problem we have here is about eggs.
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 Corner. Horse race.
Jewel wants to figure out if there is a change in proportion of eggs bought with Eggland's best eggs than with the proportion of regular Clucky eggs. In a random sample of 550 regular Jewel buyers, 51.7% had reported buying Clucky eggs. After the was changed to Eggland's best eggs, the proportion had grown to 56.4%. Is this evidence that there has been a change in proportion of eggs bought by changing brands? To begin this problem, we must figure out the parameter of interest. The parameter of interest is the proportion of eggs.
The next step in our hypothesis test is to make a hypothesis. So, we have to write our null hypothesis. The null hypothesis deals with the claim that there is no difference from the baseline. In our problem, the baseline is 0.517. So, our null hypothesis is P equals 0.517. Our null hypothesis, which focuses on the deviations from the null hypothesis, is, in our problem, P does not equal 0.517, which is the proportion of Clucky eggs reported being bought.
Wait! Can't forget our assumptions and conditions. To begin, independence, randomness, 10 population, and a large enough population condition. Let's begin with independence. Independence isn't written in the problem, so we have to assume it. We can assume that buyers do not influence each other. Check. Randomness. We were told in the problem that there was a random sample of buyers, so that means we can check that one off. Our next condition is the 10% condition. We can assume that 550 Jewel buyers would be less than 10% of the population of the United States. So we can check that one off. Our final condition is the large enough condition. we have to use our formula n times p to give us whether it's greater than or equal to 10, and n times q. So we use 550 times 0.517 is p, and then our other equation is 550 times 0.483, and both of those give us a value greater than 10. Leaves it short. Therefore, our model is appropriate.
Then state we will be conducting a 1 proportion z test. So we will write, I will be conducting a 1 proportion z test. Here I will do the math. Our first equation, the standard deviation of p hat equals our first equation. Then plug in the numbers. Over a population of 500 that is equal to 0.025. Then I use this in the find our z. Is our equation? Plug in the numbers. Then, answer 2.44. Now we'll use this to find our p value. P equals 2. We do this twice because this is a two-sided alternative hypothesis. 3 greater than 2.4. 2 times 007, which corresponds to the z on your z table. Then multiply it out, which equals your p-value. Our p-value is 0.0146. Here's that math again, just in case you missed it the first time.
And distant chatter. Hard to concentrate, yo.
So this is our conclusion. Because our p-value was so low, we reject the null hypothesis.
This is strong evidence that the ratio of eggs is not equal to its regular level. It appears that the proportion of eggs may have increased. Jules should probably continue to use Eglyn's best eggs. We are now finished with the problem.
Did you understand it?
It's all clear to me now. Thanks, Mr. P. Hopefully I won't fail now like I have been all year. Then I might have to rely on a racehorse for the curve of my final.
That's crazy talk. Statistics.
Lord, what you did to me is I spent all my years in believing you, but I just can't get no relief.